Hello everyone. In this video, I'm going to explain about nuclear energy. So once we switch over to nuclear energy, there are many advantages. For example, it fights climatic change and provides 24/7 carbon-free electricity. But the question comes, how to treat the highly radioactive nuclear waste? Well, that is what I'm going to explain in this video. Starting with the first technique to treat radioactive waste, that is the storage method. In this method, the highly radioactive waste is kept in steel cylinders, which is further placed in a concrete cylinder. These cylinders serve as a radiation shield for nuclear waste. So in general, it stops the harmful radiations from reaching outside. So these are some of the benefits of storage method. It is relatively inexpensive. It doesn't require location and transportation, as well as it is convenient to retrieve the waste from those storage cylinders from future reprocessing. So what is processing? Reprocessing involves taking waste and separating the useful components from those that are unuseful. And if we talk in context of nuclear energy, then it involves the taking of fissionable material out from the irradiated nuclear fuel. However, this method has two advantages, that is, in general, the reprocessing would allow the fissionable material to spread, which can lead to hazardous dangers, and it would also lead to nuclear purification. Coming on to the next, that is transmutation. So basically, this transmutation method is the process of converting a chemical element into a less harmful chemical element, that is, in reducing the radioactive of the nuclear waste. There are a number of advantages of this process. For instance, it provides enough isolated time for the nuclear waste to become a non-fissionable material that poses little or no risk for further geological storage. So what is the process of geological storage? Geological storage is basically storing the waste underground or under the ocean. But under the ocean, it serves as many disadvantages. For instance, the nuclear waste may spread out under the ocean, and therefore it will be very difficult to monitor it and control the spread of the fissionable material out in the ocean. Apart from these methods, there are a number of other methods such as chemical precipitation, ion exchange, and wet oxidation, which are basically reducing the volume of the nuclear radioactive waste. But the ultimate solution to the nuclear waste problem is the vitrification method, which is basically, it's a process which is being used to stabilize and encapsulate the high-level radioactive waste by converting it to glass material.
Decades, a new process has become popular. It's called vitrification. And this is where we mix the waste with sugar and put it into a heated rotating tube and then turn it into glass. It's still radioactive, but it's way easier to handle and store than liquid waste. And it also takes up a lot less space because it winds up boiling down all the water volume, and it doesn't need to be surrounded with concrete when it's buried. The problem is that the process is crazy expensive. But researchers at the University of Sheffield think they know a way to simplify the vitrification process. They've figured out a way to use slag from blast furnaces. It's basically the waste products from refining metal ore instead of sugar. So we would be using waste to get rid of waste. And apparently it works so well in tests that it gets rid of up to 90% of the volume of the waste, meaning we use much less space to store the stuff, so we're not close to running out of room to keep it in.
So, here was a video regarding the new solution to nuclear waste disposal. Now, coming on to a case study about how US tackles the nuclear waste disposal. As we know, US is the most developed nation in the whole world. As apart from this, it has 104 nuclear power plants. If we take a rough idea, then we can imagine how much nuclear waste that these 104 nuclear power plants would generate. Therefore, there is an immense need for the US to trade the waste in a number of ways. Here is an example of HANFORD vitrification treatment plant that has been set up in US. Now, US, much of the waste there is stored in 177 buried tanks as a combination of both high level and low level waste. Another cost-effective method to use the nuclear waste is to make weapons using that, where the plutonium for the US weapons is produced in the HANFORD nuclear vitrification site. So here is a video about the HANFORD nuclear vitrification site.
65 acres. The plant includes 4 major nuclear facilities: pretreatment, high-level waste vitrification, low-activity waste vitrification, and the analytical laboratory, as well as 20 support facilities and extensive underground systems. A team of highly qualified engineers and other professionals, skilled craft workers, and suppliers from around the globe has been assembled to address the challenges of treating Hanford's unique waste. This expert team understands the importance of performing quality work and working safely. Treatment begins with the transfer of waste from the current storage tanks through an underground pipe-in-pipe system. The waste arrives at the VIT plant in the pretreatment facility, where it is concentrated by removing water and an evaporation process. Solids are filtered out.
So, and the link to this video has also been given in the about section of this video. So basically, in this method, the highly radioactive waste is mixed with glass and then it is put in a heated rotating tube, and that is where the conversion takes place to glass. So it is a very efficient method and it has been used in a number of nuclear power plants in Europe. But it also has disadvantages. Only one disadvantage, although, but still, the glass produced is still radioactive and needs to be stored somewhere. So basically, in this method, the volume of the radioactive waste is reduced. It can be stored and handled easily, as well as here are some advantages. And the solubility is low, therefore it reduces the chances of groundwater contamination, as well as the resulting solids is then likely to be packaged, which provides additional barriers to the nuclear radioactive waste that acts as a shield. But there is a specific need onto the switching on to renewables and superconductors, which are the future of a sustainable green city. Therefore, at the last, the conclusion is, while spending so much of resources on the nuclear power plants, we can just switch to the renewable sources of energy and make them more efficient for energy generation. And the link to the website and link to all the videos that I had explained in this video have been given in the about section. Thank you.